One day it's rainy, chilly, like find all your potatoes, they have been hit by this disease. The potato leaves, they turn brown and black. So that is how the disease manifests, and the potato is not able to produce the tubers.
So in the evening, let me get this. In the evening, you may actually sleep, and then in the morning, that's what I've had actually.
Yes.
That in the morning you will sleep, you look at your shamba before you go to sleep, and you are very happy with your crop that it's green, it's flowering, everything is going on very well. In the morning, you wake up and everything is drying up.
Yes, actually, in some other people, they say it's like a bad omen, or the crops have been bewitched or something like that. The disease is always there. The pathogen is always there. It only needs the right condition. Like now when it's raining and it's chilly. When the environment is right, it strikes and, devastates the potato. And from one evening, like you say, to morning, you find all your potatoes, they have been struck by the disease. And most farmers, they don't follow the disease management programs. So in developed countries, whenever they see this kind of weather, they start to use chemicals even before the pathogen starts to cause the disease. So it's very serious.
Wonderful. There's something else that I've realized when I'm talking to scientists in recent past, that some of these crops, first of all, I want to ask, is potato our indigenous crop? First of all, because I've talked to scientists working in other crops, and I'm shocked to realize what we call ours is actually not ours.
No, potato is not an indigenous African crop. It was domesticated in South America. Then it migrated north to Europe. Then it came with the Europeans here. Okay. So that's how it came here.
And shockingly, it's one of the top. Is it top 3 or top 4?
In Kenya, actually, it's the top 2 crop after maize.
Wow.
Yeah, potato is a very popular crop, especially with the young people right now, with the fast foods, French
fries, yeah, of course. Everywhere
the kids, they like eating the chips all the time.
True.
And also the crisps. So it's a big crop.
Great. Yeah. So now take us step by step. How did you develop the GM potato?
So like I said, now as biotechnologists, we had to come with solutions for this problem.
Yes.
And as scientists, we know the sources of resistance. So we identified the sources of resistance, and we partnered with, with groups in Europe, in the US,
yes,
who were able to offer us these tools that we can use to develop the resistant potato. So we acquired the genes. Basically, is to transfer the genes into our farmer-preferred varieties.
And where are we getting these genes?
The genes are from wild relatives of potato, or potato that grow in the forest by themselves. These potatoes don't get the lead blight disease. So the genes were identified, and then now we are using those genes to transfer into our farmer-preferred varieties.
Okay.
Yeah.
Great. And when you're doing this, of course, there is maybe before I get to what other people are saying about the technology and so on, what is the main difference between the genetically modified potato and the other one that is not improved?
The difference is, like I said, our improved potato has lead blight resistance, this disease. So we have transferred to it the genes that make it resistant to the disease.
Other than the resistant, are there other significant difference from the other?
No.
In terms of nutrition?
No, all the studies we've done, and we just actually in Kenya submitted an application to release this variety. The studies that we did show that it is the same as the conventional potato, only that it has the resistance to the lead blight disease. That is the only difference. But all the qualities, the taste, the cooking, everything else is the same.
Great.
Yeah.
Now, from a general, been a lot, and this is within the public domain, that there's been a lot of concerns about this technology, genetically modified or genetically engineered crops or products, about the technology and so on. There's been a lot of concerns. What is the latest research, or what is it saying about the safety, if you look at the latest research?
Yes, of course, there are a lot of concerns, and we try as scientists to address those concerns. We try as much as possible, and that is that's why I say before we release the varieties, the improved biotech varieties, we have to make sure that it is safe to be consumed by humans, to be eaten by animals, and to the environment, it is safe. So we have to do all the tests, the scientific tests that qualify for it. And this has to be also validated by the National Biosafety Authority, which is an authority that is mandated to approve these GM products.
Because I actually wanted to ask you if you're doing these regulations, you're the ones who are regulating yourselves, or there's an external body that is actually overseeing these regulations?
Oh, by the Kenyan law, it is a requirement that all research on GM has to be regulated by the National Biosafety Authority.
Okay.
So they oversee all the work that we do in Kenya. And in other countries, they have similar agencies.
Great. Now, in terms of, let's look at the GM potato. Where are you doing this project? Is it just in Kenya, or you're also doing it in other countries? And probably, what is the reception or the progress of the project?
So in Africa, actually, now we have more and more countries that are receptive to this technology.
Yes.
Some countries have actually, released and are consuming GM products, like Nigeria. They released the cowpea that is resistant to insects, and it's being consumed and received very well, appreciated very well. In South Africa, they have had the also insect-resistant maize that is like, being grown by most of the farmers. And now Kenya, Rwanda, Malawi, Sudan, they have products that are on the pipeline to be released. In Kenya, we have the insect-resistant cotton that was commercialized.
Yes.
So we like to have these products in countries that have, this regulation, the laws that can allow the adoption of the crops. Okay. So for the biotech potato, we are working in Kenya, Rwanda, and Nigeria initially. But we have prospects with the resources being available to move to other countries where we have a enabling environment for the adoption of these varieties.
Maybe you can tell us, for how long have you been doing this research on GM potato, and what stage are we right now? What are some of the achievements that you've had along the way?
Oh, we started quite a long time in my organization, the International Potato Center. The research started there about in 2008, getting the genes, negotiating for genes to be, these tools to be, royalty-free, freedom to operate for the products that come from this research. And then we started now to do the research in Africa. So in Africa, initially, we had a very good environment in Uganda. There were prospects that Uganda was going to have a biosafety law. And that's where we began in 2015. So we did, once we finished the work in the lab and the greenhouse, so we began field trials in the field to see how the variety is resistant in the field in 2015. And then in the recent years, 2021, we got some resources to start the work in Kenya and Nigeria. And we have tested these varieties in Kenya and Nigeria. And now in Kenya, we have actually submitted an application for release. It's under review by the National Biosafety Authority. And in Nigeria, we are compiling the results and the studies to also submit an application for release. And in Rwanda, we just started last year, gaining from the experiences and the lessons we've learned from other countries. Rwanda is actually going to move very fast, because I'll surprise you that our target is to submit the application for release in Rwanda this June.
This June?
Yes.
Oh, so you actually might even release it before the other countries, before Kenya, for instance.
If all conditions are right and the environment is good, it might happen. But we are hoping that for us, we'll be happy to see that these innovations are taken up by our smallholder farmers for food security and also to increase their incomes.
As the lead scientist, of course, you've been with the project since inception, and for a long time, there have been those moments where you've been feeling these are the determining moments, for us to move to the next stage. What are those moments? What are those highlights that, those moments that you felt like, okay, we need to cross this? Of course, from ideation, there's that part where you have to test the theory, see how it's going to work, then move from now theory to practical, start implementing the first step. It's successful. What are those steps? What are those key highlights for the project?
My highlights has been when we started testing, to see the resistance. It was mind-breaking when we gave the variety, the pathogen, the right conditions, and we could see clearly that it's not getting the disease. Wow. So this was something that was really, good for us. Because all this time you're working in the lab, using, you're not seeing whether you don't see that you have a product, okay? The materials in the lab, in tissue culture, until you do the real test of the plant, growing the plant like regular plant, and exposing it to the disease, and you see it's completely conventional plant, it's knocked out by the pathogen. That was something that was exciting to me. And then now, when we started doing the field trials, getting the variety out there in the field and leaving it to nature, okay? Not inoculating, just let it grow in nature.
Yes.
And then we saw the results being replicated like what we saw in the laboratory. We had complete resistance to the disease.
Because one of the things that, of course, you had mentioned earlier, it's also dependent on the areas where you are planting or you're doing these trials. Have you been able to do this in areas where there is a problem, or you are just how do you pick the areas that you're going to test the potato?
Yeah, we have to do the trials in where potato is grown, of course.
Of course.
Yes. So we have done the trials where potato is grown.
Yes.
Like in Kenya, we did it in Nyandarua, the basket of potato in Kenya.
Yes.
We did it in Molo.
Okay.
And also in Muguga. So those are the regions where you have very, heavy lead blight incidences, high incidences of the lead blight. And we saw that our improved variety doesn't get the disease at all.
And when you're doing this and you're seeing these positive results, the people, of course, I am assuming when you're planting this and you're planting in areas where we have farmers, they also get a wind of what is happening. Mm-hmm. Have they had an opportunity to look at it, see the difference as you put it, and what are they saying about it?
Oh, yeah. We've had various events where we have invited farmers, leaders, community leaders like the chief, the area MCAs, yes, and other, stakeholders to come and appreciate, these events of seeing is believing.
Okay, and seeing is believing.
Yes, okay. Events. Mm-hmm. So we've had several of those during the conduct of the trials. And in all of those events, the farmers were like, can I have this variety now.
They want to take the seed.
Yes, they were saying, where can I buy this variety? Where can I buy the seeds for this variety?
Okay.
But of course, we had to manage the expectation by telling them that we are under the process of getting the variety released, and once it is released, it will be available to them as any other seed that they've been buying before.
Now, talking about seed, one of the perceptions or the things that are out there is that when these seeds are going to take away our sovereignty as a country, as Africans, like when we employ these technologies, specifically genetic engineering, that we're giving opportunities for multinationals and therefore be able to do our seeds as we normally do it. How do you respond to this?
Okay, so we are public institutions ourselves, and also our partners, CALRO, and even the other countries where we work with the national programs.
Yes.
So we are producing this as public good. We are not doing this for profit. So this is for food security and also income for the farmers and income for the country. So the seeds that are going to come from these varieties, they are just going to be sold, and they will go through the normal seed systems.
A normal seed system.
Yes, they are not going to be sold at prime price, because we are following just the normal conventional way of producing seed.
Okay.
Yes.
Okay. What about this notion that genetically modified seeds, you cannot be able to replant them, that if you replant, they won't grow? So are farmers going to be forced to be buying every season, and
no,
why?
No. So we've done those studies. So this improved variety, they are identical to what they are used to. So the variety that we improved in Kenya, we are calling it biotech Shangi.
Okay.
It has all the qualities like the regular Shangi. They can replant it, but agricultural practices don't allow you to replant so many times, because the seed starts to degenerate. The quality you get after the second cycle, third cycle, fourth cycle is not like the one you bought from the seed producers. So it is advised, the normal practice is you replant up to 4 times, maybe 5 times maximum.
Okay.
Then you go to buy another seed. So it will be like the regular seed. It has all the qualities like the normal seed. It is not going to, you cannot replant it again.
So what you're saying is, if I'm getting you correctly, is that with this GM potato, farmers can be able to replant the first time, the second time, the third time, until the fourth time, then they go back and buy. Is that the correct position?
Just like the way they normally do, it is the same on the conventional seed.
Okay.
They can replant and up to 4 or 5 cycles. Yeah, to be sure that the disease is still disease-free. It's not exposed to other things. It has not been infected by viruses and other diseases. Okay. So it is advised that you don't replant it so many times, like 5, 6, 7, 8, 9 times.
And this is not because of just the technology. It's a practice that has been there because
it is a practice. Is recommended.
So it's not unique to GM.
No, it's not unique.
Potato or whichever other crop.
Yeah, for potato, because it's a clonal crop. When you harvest, you keep some of it for seed.
Yes.
So that is the practice with our farmers. So they'll be doing the same. They don't have to go back to buy the seed after the first, second, third, and fourth cycle.
And now that you've done this and you've tested these things in the field, in fields where the same fields that farmers will be doing or will be planting, what would you say are the environmental impacts of this GM potato?
So that's a very good question. So farmers, like I say, they use chemicals to control the disease. For this biotech Shangi for Kenya, they not use chemicals to control it. So our studies show that they use up to 12% of their production cost on buying the chemicals. So you can imagine they are going to not to spend 12% of their production costs. So they are saving, number one. So number two, the climate we are conserving the climate because we are not exposing the climate to chemicals.
A lot of chemicals.
Yeah.
Yes. Mm-hmm.
So it's good for the environment. Okay.
Yes.
And number 3, our farmers, they don't use personal protective equipment. The mask, the gloves
Mostly
when they are
actually
spraying.
don't.
They don't. Where I've gone, I've never seen a farmer wearing those personal protective
Despite the guidelines.
The guidelines on using the chemicals. So these farmers are not going to be exposed because they'll not be applying the chemicals. Yes. They are not going to be exposed to those chemicals. Yes. So it will lead to better health, of course. When you're exposed to chemicals, then your health is compromised, of course. So it's all those benefits are going to go into the farmer and into our environment.
Wonderful. What about the yields? What difference are we looking at when you're talking about the yields with the new improved varieties versus the other varieties?
Yes, that's another very good question. Because now the plant is not getting the disease.
Yes.
Because if you don't spray and the varieties is susceptible, of course you not get good yields. True. Okay. But now because the variety is resistant, we have seen that you can get up to 50 tons per hectare. And this is going actually to lead to about 34% more income to the farmers.
Okay. 34%.
34% more income to the farmers. Wow. And our calculation is that the Kenyan economy is going to gain by about 840 million Kenya shillings per year.
Wow.
Yeah.
What about tonnage? What about tonnage? For instance, for a farmer, they can look at it from a tonnage perspective and say, if I'm able to harvest this number of tons with this conventional variety, then probably with the improved, I can get how many tons?
Well, 40 to 50 tons per hectare.
40 to 50 tons.
Yes.
And ideally, what are the farmers getting with?
Oh, right now they are on an average of 10 tons per hectare.
10 tons.
Yes.
10 tons. That is like you're moving them threefolds.
Yes.
Wow.
Yeah.
That's good. I'm hoping that at least you get to get this product to farmers so that they can also benefit. Now let's talk about the misinformation and disinformation about this technology. First, have you encountered it, and how has it impacted your work?
Yes, there is a lot of misinformation and disinformation about the technology. Some of them we have talked about are things to do with multinationals taking over the sovereignty of the seeds, all those. So we are addressing that these are products from public institutions for public good. So we don't expect any profits coming out of it. People bring concerns with safety. The safety studies show that the products are safe. The products we are producing are safe. People talk about, their health, that people talk that when you eat GMO, you get cancer, but we don't have studies that show that. So most of the concerns, we actually listen to them and we address them as they come. So people say that maybe this potato or the GM variety is going to wipe out all other varieties. But I will say that farmers have a choice, and we have institutions that conserve the existing varieties, that if for one reason that some farmer or someone is interested with whichever variety they want, they can always get it.
They can always get it.
Yes.
So it's a matter of choice.
It's a matter of choice, I would say.
As you talked about those concerns, one of the concerns to many people with religious inclinations is about tampering with nature. You're tampering with nature, so whatever you're producing is not natural. How do you respond to that, and how do you navigate the ethical issues as you're developing these?
I will say, like for the biotech, I said the genes we get it from a relative of potato. Yeah. So, and this relative actually, you can use the conventional breeding to get the resistance. But the normal breeding will take so long. It will take so long because, the variety that is growing in the bush there, maybe the yield is very low, number one. So for you to get to the high yields, it will take you a long time for breeding. So basically, what biotechnology does is that you get the source of the trait you want. For us is the disease resistance.
Yes.
And you transfer the trait using the biotechnology method, the tools that we have. And what you're transferring can be transferred naturally, but it will take a long time, like I said. So it's trying to get the end result in a short time. Yeah. So breeding could have taken maybe 100 years to get
100 years.
Yes.
How many people will live through that cycle?
Will not be there. Okay. But for us, it takes us like now with optimized condition, it will take us 2 to 4 years to improve a variety. If today you brought variety X and you said, I like this variety, but I want you to improve it for lead blight, it will take us 2 to a maximum of 4 years to give you back the variety with the improved trait.
With all these benefits that you've talked about, in terms of increase, in terms of resistance, increase of the yield, you've talked about resistance to the disease. With all these positive traits about this biotech potato and generally other GM products also seem to carry a lot of positive, or they are improved, so they bring in new positive things. Why do we have a lot of resistance then? Do you think, first of all, do you think the term genetically modified, genetically engineered carries a lot of baggage?
Yeah, there's been a lot of organizations that will not like people to benefit out of this technology, so they have worked around the misinformation and the disinformation, and spreading all this into people, and people have not been well educated about the benefits. So as scientists, we are trying so hard to educate the people that this is a very safe technology. It's actually, I will say, the safest, because before we release these products,
yes,
these varieties, we do a lot of tests. Unlike conventional breeding, where you just breed a variety and you just bring it there. Mm-hmm. For us, we have to do so many tests, and those tests have to be validated, by external reviewers.
Yes.
And once they are convinced that everything is good, everything is safe, that is when the variety is released. So in terms of safety, we do a lot of work. But again, perceptions are not easy,
yes,
to get out of people. So once people they have the perception, it's GM, then they just think it's a bad thing.
Actually, it is in the word. When somebody hears GMO, first of all, there is a lot that comes to mind.
Mm-hmm.
That's why I wanted to first get you. Do you think the problem is the way we call them? Is genetic GMOs? Because first of all, if you say that, of course, somebody forms an opinion.
Yes, it's how the technology was sold initially. And the anti-technology used a lot of the terms like GM. They say GM causes cancer, GM, causes infertility, GM, all the negative.
Very sensitive, especially if someone says infertility, of
yes,
course, nobody's going to touch it.
Yes. Mm-hmm. So it is, I'll say it's an uphill task for us scientists, but we are trying our best to tell people the benefits. And I think with the time, people are going to see the benefits, because the technology has been there now for over 30 years for countries that have embraced it. And we've never had a single proven incidence, that it has caused any harm. So, 30 years is a long time. If GM could be the one that is leading to some concern A or concern B, then we could have noticed.
It's close to our life expectancy.
Yes, but yeah, I have not had any scientific proof that it has caused, health concerns and all those other concerns that have been raised.
What is the most weirdest? I don't want to call it concern, or let me call it concern. Weirdest concern or myth that you've heard about GM in your process, as you work on it. And even when you go somewhere, do you introduce yourself like, I am Dr. Eric, I work on GMO?
Yeah, the most, and the one that comes, the most concern that comes is the cancer.
Okay.
Because now we have a lot of cancer cases coming in, and actually we don't have even a single GM product that has been sold in the Kenya.
Yeah, that's true.
So
apart from
cancer
GM cotton.
The cancer incidences, they cannot for sure be associated with the products coming from biotechnology. So, but people, since their perceptions are it causes cancer, so any incidence of cancer, they try to associate it with GM, but it has not been proven.
Okay.
Yeah.
Okay.
Yeah, but that's the most that I hear all the time. People say, "Oh, this cancer, this GM."
Okay, from inception, from inception, I'd like to know you. Of course, you've talked about your highs. The moments when it was very critical for a project to move to the next stage. Mm-hmm. What about the lowest moments? Have you had that during the journey? Have you had those lowest moments where you felt like maybe I should just drop all these and just move on and get out of the lab and go become something else?
Yes. So there has been a lot of those. When you are just close to the finish line, and then maybe something like you don't have resources to finish. Yeah. You don't have an enabling environment to finish.
Yes.
You are just like, oh, this thing is almost getting out there. This, good thing is getting to the farmer's hands, and then the environment is not enabling for that to happen. So it's you feel disappointed at that time when you are almost, getting the product, into the farmer's hands, and then. Of course, you can't do this without resources.
True.
So
it's an expensive technology, research.
Yeah. So you end up, being disappointed because now you have a product, and actually, the most disappointing for me will be a good product, sitting there on the shelf. A very good product.
But
you have all the evidence that it is a good product, but it's sitting there in the shelf. And because
not benefiting farmers,
because
you had some hiccup.
Those are the low moments for someone like me, and of course maybe when we are developing this, of course maybe it takes you don't move very fast sometimes because these laboratory experiments, they take time, and some of them turn negative, some of them. So those are just a detail.
Yes.
But again, partnerships. Some partners, they don't move like you could have wanted to move.
Yes.
Even with the resources,
yes.
You feel like they are dragging, Yeah. So those are some other low moments. But I would say overall, I mean, it's very exciting when you have, these farmers or these people who see the benefit and they say, we want it like now. It's very exciting.
So would you say it's worth it? It's worth the trouble? It's worth the whole time you spend in the lab?
It's very rewarding, I'll tell you. It's very rewarding, not like materially,
yes,
but just knowing
that satisfaction.
Just knowing a farmer in Olkalau one day will benefit from this, it's very, very fulfilling.
Very fulfilling.
Yes, now, just knowing that the Kenyan economy is going to improve maybe by 0.005%.
Yes,
because of this,
it's very rewarding.
Yes, it's very rewarding. Yeah. So It's not in vain.
It's worth
not
it.
in vain. Yeah,
It's worth it.
yeah, it's worth it.
Now, you are very well established in the field. Many African countries don't even have regulations or biosafety frameworks, to enable young scientists to be able to, carry research in these areas. So I wanted to get from you, is there hope for those young scientists or those aspiring scientists who are probably still in courses in biosafety, in biotechnology? Is there hope for them?
Yeah, I will say there is hope, and technology is a wide field. Not only in crop improvement, it's on diagnostics, it's on pharmaceuticals,
Yes.
The insulin that people are using, it's a biotech, it's a GMO.
It's GM.
Yes.
Oh,
so those are areas that our young scientists, upcoming scientists, can get into. And with technologies like this, once it's accepted, once it's proven, you will see, a lot of young people getting getting involved, and maybe more and more products coming. Because you cannot do it alone. You need people. It will open up many opportunities, I think. Mm-hmm. So once it's embraced, like some developed countries, the biotech industry is among the top industries. Once it's embraced, you'll get a lot of companies established, local companies
established.
Yes.
When I was preparing for this, I talked to one of my friends, and he told me, actually, Africa, we already missed this train. Now people are no longer talking about GMOs. People are talking about new things. And here we are still talking about, okay, of course for you started a long time ago, but people are still discussing. You've not even gotten to the market yet. It's now that you are seeing you getting to the market, probably in the near future. Would you share the same view that we actually missed this train already?
Yes, we are. Africa is missing out on the benefits of some of the technologies like biotech.
Okay.
This is a technology that should have been embraced long time ago, and by now, some of the things we are doing, like importing food, could not be happening because we don't attain the productivity that we are supposed to. Because and solve ourselves
the diseases and
all those. And some of the solutions, they can be solved here, homegrown solutions. We don't need to, these technologies now, we don't need people to come from outside. Yeah. So we can solve the problems ourselves. So I'm thinking like biotech, we shouldn't be, talking at this level, whether we should adopt it or not.
Yes.
Let's adopt it. Let's embrace it. The countries where this has happened, some South American countries, big countries, they have benefited from this. And we end up sometimes importing the same products from them when we are in a crisis.
Or byproducts.
Yeah, byproducts from them. So I will say, if we can, this is the first step. I will say this is the first step. We have lots of opportunities. Once people are starting embracing the technology, you'll find, other products coming. Yeah, within us. Yeah,
yes.
I wouldn't advocate if we are able to get products ourselves to start importing.
Okay.
Yeah,
because we become a market now.
Yeah.
We don't empower our own farmers now.
Yes,
we're empowering farmers from another place who are not going to get money. Okay.
Yeah. Let's get our young, scientists coming from universities or students joining hands with established organizations like Calro, like us, developing new products. Because now we have everything. I don't think we are lacking anything.
In terms of capacity, human and infrastructure.
Yeah, and, there's a good framework. Yeah.
For people to actually do. Now, one of the challenges and one of the things that I hear people mentioning a lot, Africa and Kenya for that matter, most of African countries look up to Europe, and they discuss about, okay, if we grow this, then what is going to happen to our market? Like our products are going to be banned. We're not going to be able to sell it to other countries, to Europe, to be specific, because Europe have quite stringent measures put in place. So I don't know. How do you respond to that?
In terms of food, I think we are a net importer than exporter, I would say. So what we export actually is very small, and it's maybe the floriculture industry, horticulture, and some others. But for the main staples, for the main consumed food products, they are from here, and we rarely export them. So I will say for those, let's just embrace like biotechnology to increase our productivity, because we are just making them for us.
Yes.
Okay,
we're first feeding ourselves first.
Yeah, we should think about ourselves first. Yes. So once we are stable, Europe, they were stable long time ago. Okay, self-sufficient long time ago. So we are not self-sufficient yet, so we should work hard to be self-sufficient. We should work hard to be food secure.
Their challenges are not ours.
And that's why maybe some countries don't embrace biotechnology, even though they will go ahead and buy biotech products from other countries, but they don't embrace it because they have the resources, they have the money to buy those products. They don't want to grow them. Yeah. So for us, it's smallholder farmers who feed us.
Yes.
And they face these challenges that some of them, they don't know what to do when they are faced with these challenges. I've gone to the field many times, and I find a small, like maybe a quarter an acre, not even half an acre, and you find the diseases wiped out the whole crop. And I just ask myself, so this farmer has lost the crop. They're not going to harvest anything. You can imagine.
After 3 months of hard work.
Yeah, you can imagine. So if we came up with a solution for them, and they are the ones who feed us, then we become food secure.
Okay, great. Yeah. So maybe as we wind up, you can just look at that camera and tell those ones who still have reservations about biotechnology, about specifically biotech potato, those ones who haven't heard of it, of course, and those ones who have not, but now they're going to hear of it. What can you tell them as we conclude?
So I would like to say that biotechnology is one of the tools that is being used to solve some of our problems. And in agriculture is actually a technology that has been tried in many, many, many countries. And throughout the production and, the products that have come out of there, it shows that there are no negative effects that have been associated with the technology. In Africa right now, we have all that it takes. We have the scientists, we have the tools, we have the technology to use responsibly this technology. And in many countries, they have the law that regulates, the production and the consumption and the development of these products. So I will say that Africa has an opportunity to utilize this technology that is going to benefit all of us. And what I'd like to say is some of the concerns that have been raised, we have tried to address them. We have, as scientists, before we release these improved or products coming out of the biotech, we have to do all the tests that show that it is safe to humans, to animal consumption, and also to the environment. So I can assure the public that as scientists and as regulators who are involved in this, that they work so hard to ensure that the products that come out of these are safe for the human and also for the environment.
Wonderful, wonderful. I can't fail to thank you for making time for us. And as you put it, we have to always think about ourselves. So Thank you very much for joining. That has been the man himself, Dr. Eric Magembe, talking to us, shedding light on about GM potato. And we are very grateful that you could make time for us. And we appreciate your views.
Thank you.
And now I believe a lot of our audience now knows something new about the potato and what they need to do.
Yes, they feel free to ask me any question. If you get any concerns, we are ready to address them.
Okay, great. Thank you very much. So that has been Dr. Eric Magembe, the lead scientist on biotech potato. And as he said, let's put Kenya first, Africa first. We put ourselves first, and then we can worry about the concerns that other people have about market and other things. So that has been it. This is Africa Science Dialogue. See you in the next one.
Africa Science Dialogue.